This is what most people think a black hole looks like. A giant cosmic vacuum cleaner floating in space, waiting to swallow anything that gets too close. But the reality is actually much stranger, and honestly, much cooler. Around a black hole there is a glowing ring of superhot gas called the accretion disk. This gas spins incredibly fast, heats up to millions of degrees, and starts glowing brightly. Then there is the famous event horizon, the point of no return. Cross this boundary and nothing can escape, not even light. And at the very center lies something even stranger, the singularity. A place where matter is crushed into an incredibly tiny point and the laws of physics basically throw up their hands and say, yeah, we're not dealing with this today. But you might notice something strange about the glowing disk. One side of it appears brighter than the other. That happens because the gas is moving incredibly fast, almost the speed of light. The side moving toward us looks brighter due to something called Doppler beaming. Now here's the funny part. That beautiful image of a black hole you always see online? It's actually a simulation. The real picture of a black hole looks, well, a little more like a glowing donut photographed with a potato. This blurry orange ring is Sagittarius A asterisk, the supermassive black hole at the center of our galaxy. It was captured by the Event Horizon Telescope, which linked observatories across the entire planet to create a telescope the size of Earth. And after all that incredible technology and global cooperation, humanity's first picture of a black hole looked like a slightly burnt bagel. But that raises an important question. Where do black holes actually come from? The story begins with massive stars. Inside a star there is a constant battle happening. Gravity pulls everything inward, while nuclear fusion pushes outward. As long as these two forces balance each other, the star stays stable. But eventually the star runs out of fuel. When that happens, gravity suddenly wins the fight. The core collapses extremely quickly and the star explodes in a massive supernova. What remains is an object so incredibly dense that gravity becomes almost unstoppable. Space itself begins to bend inward, creating the region we call a black hole. Once something crosses the event horizon, even light cannot escape. That is why black holes appear completely dark. The physics that explains all of this comes from Einstein's theory of general relativity. Einstein showed that gravity isn't really a force pulling things together. Instead, massive objects bend space and time around them. Imagine placing a bowling ball on a trampoline. The surface bends under the weight. Now imagine the bowling ball weighing more than a star. But here's where things get even crazier. Most black holes don't just sit there like a lazy cosmic potato, they spin. When scientists tried to describe a spinning black hole using Einstein's equations, the math became extremely complicated. In 1963, a physicist named Kerr solved those equations. The result was something called the Kerr Metric. And if you look at the equation, it looks less like physics and more like your calculator had a complete breakdown. But what it describes is incredible. A spinning black hole doesn't just rotate by itself, it actually drags space and time along with it. Imagine stirring coffee with a spoon and watching the liquid spin around. Now replace the coffee with space-time, and the spoon with a black hole the size of a city. Physicists call this effect frame dragging. I call it the universe saying, geometry? Yeah, we're done with that. Black holes aren't just cosmic monsters. They are some of the most extreme laboratories in the universe, where the laws of physics are pushed to their limits. And things get even stranger when we start asking what actually happens inside a black hole. So stay tuned for the next part. If you want a deeper explanation of how black holes form and why they matter, check out the full article on my blog, Simplified Science with me. Link in the description.